Alright. So mostly we are studying particle kinematics and particle dynamics. Because our body we treat it as a particle. Isn't it? But in many circumstances we come across composite bodies. Composite bodies are big bodies, extended bodies which are made up of more than one particle. For example, a rope, a chain, etc. etc. So when you come across questions based on composite bodies, and particularly you have to find out the work done by the gravity, work done by the force of gravity, that is work done by weight, then you have to use the concept of center of mass concept. Okay. Here for small bodies we know there is no discrimination between center of mass and center of gravity. Center of mass and center of gravity will be different only if acceleration due to gravity changes over the body, over the premises of the body. To whatever extent the body is there, over that extent, if acceleration due to gravity changes, only then center of mass will be different from center of gravity. For example, a big mountain, as you go higher and higher, acceleration due to gravity reduces. So what will happen? Center of gravity, G will change. Center of gravity will be different from center of mass of a mountain. Similarly, a deep ocean. So as you go below the Earth's surface, again G decreases. You know that G is zero. Acceleration due to gravity is zero at the Earth's center. So as you go on, going deeper and deeper, G reduces. So again, for an ocean, center of mass and center of gravity will be different. But the bodies involved in our question, a ball, a chain, a rope, a block, these are small bodies. So you need not discriminate between center of mass and center of gravity. Both are same. So in such case, in extended bodies, you have to assume that the weight is concentrated at its center of gravity, which is same as center of mass for small bodies. And then you apply particle kinematics. Are you getting the point? Apply the particle kinematics. Is it clear? Let us take a question. Take a question. See here. See, total length of the chain is given as capital L, okay? Capital L. A length small l is already hanging, okay, from a table surface. All surfaces are smooth. We are avoiding friction so that the problem remains simple. We just want to know how to apply work energy theorem. It is released from this position. It is released from this position. The question is, you have to find the speed of the chain when it just leaves contact with the table. Okay? Mass, you can take it as n. Is it clear? Note the question. Note down the question. The chain shown in figure is released. The chain shown in figure is released. The chain shown in figure is released. From the position shown in figure. From the position shown in figure. Also, find its speed. Find its speed when it just leaves contact with the table. Find its speed when it just leaves contact with the table. When it just leaves contact with the table. Okay. So here again, this is the initial situation, and when the chain just leaves contact with the table, the chain position will be like this. This is the position of chain. Okay. It just leaves contact with the table. So we have to be, as I told you, we have to be very clear between the two positions between which we are about to apply work-energy theorem. So we are about to apply work-energy theorem between this situation and this situation. So work-energy theorem states that sum of work done by all the forces is equal to change in kinetic energy. Okay. So here you see, here you have normal reaction, you have weight of the portion which is hanging, plus here you have the weight. Okay. So if I take this as small mg, then here it is what you call capital M minus small m. And for vertical equilibrium, we require that normal reaction will balance the weight. Of course, as it descends down, these two forces reduce because the length of the part of the chain starts reducing. So mass of the chain will reduce, which is above the table. So normal reaction also, they are variable force, doesn't matter. So here I will write work done by this weight, which is of course variable, plus work done by the normal reaction, which is again variable, plus work done by the weight of the portion which is hanging. So we have assumed V as the velocity with which the chain leaves contact. Initial velocity is 0, of course, because the chain was released from rest. So these two will be 0, isn't it? Because displacement of the chain is, in fact, point of application, displacement is to the right, horizontal, whereas forces are vertical. So angle between them is how much? 90 degree. Cos 90 degree is 0. So even though forces are varying, but in each instant, F as cos 90 will be the formula. F may be variable, doesn't matter, but cos 90 is fixed. So cos 90 is 0. 0 multiplied by any number is 0. So don't worry about this. So now we have to find only this. You know that work done by the gravity is equal to decrease in its potential energy. Earlier we have studied all those things. Work done by the force of gravity is also equal to decrease in its potential energy. And this is true for any conservative force. In any system full of conservative forces, work done will be equal to reduction in its potential energy. You have to think like that. You have a bank balance. Okay, suppose you have a bank balance of 50,000. When you enter into college, you will have to open account. Bank will come and sit in your college and they'll force you to open account. Without account, you can't manage, no? Lot of fees has to be given, lot of things are there. So most probably they will open an account. So you'll have an account sooner or later. Don't worry about that. Okay? So that is the potential energy. The potential energy of a system is your bank balance. You are the system. Potential energy is your bank balance. Your expenditure is the work done by the system. You are the system. You are spending money. So system is doing work. So work is just like expenditure. So if your bank balance is 50,000 and if you spend 10,000 rupees going to a mall and purchasing clothes and shoes, etc., 10,000 you spend, your bank balance will reduce to 40,000. So decrease in bank balance is 10,000 because you spend that 10,000 in purchasing something. Similarly, if the potential energy of a system is 50,000 units, work done by the system is 10,000 units, so that potential energy will reduce by 10,000 units, and now the potential energy will be 40,000 units. So potential energy is just like your bank balance, and work done by you is work done by the system, because you are the system. One more thing is also there. It's not that you can only spend money, but your bank account can increase also. For that, others have to spend money on you, isn't it? Suppose father, mother, uncle, whoever is your guardian, he has to spend money, he or she has to spend money on you. Then that will be an expenditure for them. Suppose your father transferred 20,000 rupees into your account. Expenditure for your father is how much? 20,000, because it's gone into your account. So that 20,000 is no longer in the position of your father. So for your father it is just a expenditure, because went 20,000. Now you gained your bank balance. Suppose initially it was 50,000. Now your bank balance will show 70,000. So work done by external body. Father is external. You are the system. Any other outside person is external. So for him it is an expenditure. So work done by external body is equal to increase in your potential energy. But when you spend yourself the 10,000 rupees to purchase anything, your bank balance will reduce. So it's same thing in case of conservative forces. When work is done by the system, its potential energy will reduce. But when external agency does work against the conservative forces, potential energy will increase. Simple as that. So what I'll do, best thing is I'll take the what? This as decrease in potential energy. Decrease in potential energy is equal to this. Okay? So decrease in potential energy, then you have to decide a datum level. Based on that, datum level is a reference level. Based on that, you take potential energy as 0. Is it okay? So what I'll do, I'll take this as the datum level or reference level. So decrease in potential energy, initial minus final. So whenever it is decreased, that means initially it was more. Change will be final minus initial, but here we want positive value. So positive value means decrease means initial minus final. So initially this part had 0 potential energy because it was already in the datum level. Potential energy in the datum level is 0. Then this will have, I have taken M. M is this. If I take mass per unit length as lambda, lambda is equal to mass per unit length. Then I will have mass per unit length into length as the mass mg. As I told you, for composite body, imagine the entire mass to be concentrated at the midpoint, because for a uniform body, center of mass lies on the midpoint. So, and it is below the datum level, h will be negative. If it is above the datum level, h is positive. Below the datum level, h is negative. So minus small l by 2, because this small l, so this l by 2 minus. So minus l by 2. This is the initial potential energy. For this it is 0 and for this it is minus final potential energy m g into h. Because the total mass is concentrated at the midpoint. So this height is L by 2, capital L by 2, and with a minus sign because it is below the datum level. So this should be equated to half mv square. Okay? So therefore, I can take, this will be lambda into L, lambda into L. Mass is lambda into L, total mass. Later, at that time, substitute lambda equal to m by L, don't worry, capital M by L. So this capital M, I have taken lambda L. So now what all things are constant? Lambda into g by 2 is constant. So capital L square minus small l square. Isn't it? This will become plus. So lambda is what? Mass per unit length. So m by L, g by 2 into this. So mass will get cancelled anyway. So this, therefore 2 gets cancelled. So V is equal to under root g by L into capital L square minus this is the velocity. Final speed with which the chain leaves contact with the table. Okay. Is it clear?